So today, what we will discuss is we will try to talk about this particular thing, a simple case study. So that you will get an idea about what types of models actually we develop in machine learning or data science. So I will try to give you a very simple example. We will try to take a simple problem statement. First of all, try to understand what is the problem statement. As we want to discuss about a case study, I will try to show you a problem statement. Definitely, we haven't discussed any of the algorithms, but still, as case study is given there, so that's why I will try to show you a problem statement, and then I will try to show you the implementation of that problem statement, or what is the final output you are going to get, or final output you will be able to see. That's what I will try to show it to you. So as a case study, we will try to discuss that, and obviously it is actually developed in Python language, right? So the problem statement which we are going to solve in that, obviously it's a machine learning model which is developed, but yeah, it makes the Python, and we have used a very basic algorithm in that, and that is called as linear regression algorithm, which for your case we haven't discussed about linear regression yet. But still, at least you will be able to understand what is the problem statement and what it is doing. So as a case study, what you can do with the help of machine learning, that's what I want to share to you. Right. So that's why if you people remember, I told you that ideally they should have actually explained or they should have put these contents in the first or the second unit instead of third unit, right? And then there will be PCA and other things. Okay. But yeah, as it is there in syllabus in this way, so no problem. Maybe in the third unit anyway we are going to discuss linear regression in detail, and at that time I will be explaining each and everything step by step. So what is the linear regression algorithm? What is the mathematics behind that? And how to implement linear regression algorithm and how to create the model file. So here we will try to discuss a simple problem statement in which we want to do prediction. Always remember, whenever I say prediction, you can call prediction as regression also. Okay, so as a case study, I want to show it to you. This particular example I want to show. So we will try to create a prediction model or a regression model, I can say. Now, what is that problem statement? So see, the problem statement is something like, you know that, for example, uh, if there are students who wants to go for Master of Science at MS in foreign university, or maybe if there are some people who want to go for PhDs or higher education in foreign university, right? So you might be knowing that you need to appear for some exams. Whenever you are going for, or you are planning to go for MS in some field, you need to appear for exams like GRE, right? So there is an exam like TOEFL, right? And so the scores of these exams actually they matter whenever someone wants to go for MS in foreign university. So these scores are actually considered, and obviously there are other exams also. So other than these, there are other attributes or other features, or maybe there are some other things for which there is a weightage to get the admission in MS in foreign university. So GRE score is there, TOEFL score is there. Then there is something called as, so see, you might be knowing that whenever you are going for some research or whenever you are going for MS, you are generally asked to present some statement of purpose, SOP. This also SOP is the thing, but statement of purpose, that means if you have done some work, right, if you have done some research or anything whatever you have done, so what is the statement of the purpose, what is the statement of your research in a short. So for that also there are some marks. Okay. And other than that, then there is for example, maybe CGPA is nothing but the marks which you have scored in your graduation, for example. Or you might be knowing that whenever, or you might have seen your seniors, uh, they actually ask the project guides or the principals or the HODs for letter of recommendation from the college. So yes, uh, in letter of recommendation, it might be dependent on your behavior in the class or in the college or in the premises and so on, right? Or maybe okay, yeah, people wait for some time. Okay, do not send your roll numbers and names. Do not send. Pankaj Kumar. So GRE score, TOEFL score, statement of purpose, CGPA, letter of recommendation. right? So letter of recommendation generally you get from your principal or HOD or project guides, and then there is something like maybe whether you had done some research or not, yes or no, right? So if you had done some research, obviously there will be a higher weightage or higher chance that you will get admission in good university. Okay, and so GRE score, profile score, statement of purpose, CGPA, letter of recommendation, and research done or not, whether the research is done by that person or not. So depending on all these parameters, depending on all these features, it will be decided what will be your chance or chance of admin. So suppose just assume that we have this kind of a data in which these are the features, these are the columns. GRE score is there, profile score is there for a particular person who wants to go for MS in foreign university. CGPA is there, LOR is there, research is there, or one more thing is there, that is university rating. That is the university in which you are trying to complete your graduation or you have completed your graduation from. So what was the rating of that university, right? So maybe on the scale of 1 to 5. So CGPA is on the scale of 1 to 10. Letter of recommendation is out of 5. Statement of purpose is out of 5. Profile score, you might be knowing that it is out of 120. GRE score is out of 340. So, how many marks a student has actually got? Depending on all these things, what was his chance of admission? So suppose we have this kind of a data. Now what is our purpose? Our purpose is to create such a model. If one student comes and he enters all his values, right, all these values, so our model should be able to predict what will be the chance of that student to get the admission in foreign university. This is what our problem statement is. I hope everyone is able to understand that. See, those people who joined late, I'm just trying to discuss about case study. So I just introduced you what is the case study. So we want to create such a model which is going to help us to predict the chance of admission of a student to get admission in foreign university for MS, depending on his GRE score, profile score, statement of purpose, CGPA, letter of recommendation, university rating, and whether the person has done some research or not. So out of all these features, out of all these columns, this research is actually a categorical data because it has only two values, either yes or no. For example, yes is 1 and no is 0, right? So it is called as categorical data. So depending on all these features, we need to create such a model. So for example, you have 500 records. You have the data of 500 students, previous 500 students who have actually taken admission in the foreign university, and we have their chances of admission. So this kind of a data you already have. Now, our purpose is to create such a model which is going to help us to predict the chance of a new student who will get the who will try for admission in foreign university. Right? This is what we want to do. Now, what I will do is I will try to show you the data set. What type of a data set we have? Let's try to look at the data set first, and which will be having all these features. Whatever I have shown you just now, so you will be able to see the same features. So let me go and try to show you the data set itself. Okay, so you will see that it will be having all those features. So this is the data set. So this data set is in CSV file. I already talked about CSV file, right? CSV is a comma separated value. So you know that by default the separator or the delimiter in case of CSV file is a comma. That's why it is called as CSV. I think we have already discussed, right? CSV actually stands for what? Comma separated value. So this is a CSV file which I have actually opened in Microsoft Excel. That's why it is looking like this. Now you can just check here in this comma separated value, this CSV file. Just check all these features. Serial number is there, then GRE score, profile score, university rating, statement of purpose, letter of recommendation, CGPA, research done or not, and what was the chance of admission of that student to get the admission in foreign university. For example, if you take first student, he scored 337 marks out of 340. So I told you GRE score is out of 340. So first student has got 337 marks. Profile score is out of 120. First student has got 118 marks. University rating is out of 5. So for the first student has completed his graduation from the university, which was having rating as 4. Statement of purpose, it was again out of 5. So someone has got 4.5. First student has got 4.5. Letter of recommendation, this student has got again 4.5 for letter of recommendation out of 5. CGPA is the marks scored on a scale of 1 to 10. So this student, he is having the CGPA of 9.61. And research one means yes, he has done some research. And this is the chance of his admission. So 92% is the chance of the admission of that student to get admission in foreign university if these are the things which actually he has scored, right? So try to understand whatever you are able to see. This is the data. Just assume that this is the data which is given to us by client. Okay. Now depending on this data set, so you can see how many number of features we have. One, two. So see, serial number one, GRE score two, TOEFL score three, university rating four, statement of purpose five, letter of recommendation six, CGPA seven, research done or not eight, and chance of admission 9. So total 9 features we have. Now try to understand here. If you people remember, I talked about training and testing data set, right? So here, as we want to develop a prediction model, out of all these features, this chance of admission is your target column. Okay. So target column or target we can target feature, or we also call it as output or output column, or we also call it as label, or we also call it as dependent feature. These are the different terminologies which are used for the same thing. So chance of admission is going to be your output, and all the other things. Okay, Manas is asking, sir, how was the chance of admit calculated? Was it in the dataset already? Yes, Manas, it was there in the dataset already. It was calculated how. So this data is actually given to you by the client. From this data we are going to train our model. Are you getting, Manas? So it was already there. For example, just imagine, see, it can be a data from a doctor also, from hospital also. So you want to create a classification model, and you want to create a classification model to identify whether the patient is affected by COVID-19 or not, positive or negative. So obviously you will get that data from hospital only. So depending on the symptoms of the patients, is going to note, okay, he is positive, he is negative. So that is the data which we are going to make use of to create the model or to train the model. For example, you want to develop a model in which you want to predict how many runs a particular player is going to score in the next match. So obviously, what are you going to require for this? You are going to require his history, what he has done on this kind of grounds. So depending on, so obviously in that case you will be having one column that is runs, and which are already there. Or you can take a simple example. For example, you want to create a model in which you want to predict how many marks you are going to score in the next exam. So obviously, for that we need your marks which you scored in your previous exams, right? So how you study actually, what was your history? Depending on that, what we can do, we can show that data to our machine, and depending on that, we can train our machine that in future, if this same person comes with these input features, what will be the output? What will be his output? Or what will be his? What will be the score what will be the marks he will score in the next exam? Right. So obviously, these are the ready-made values which we got from the client. So even this is the output column. If you people remember supervised learning, what did I tell you? I told you that in supervised learning, we are in advance aware about input as well as the output. That's why it is called as supervised. There is a supervisor, right? So input and output. So input columns are also called as independent columns, right? This is the term which we use for input columns, or we also call it as input features, right? Or attributes we can say. So these are our input features. And obviously, out of all these input features, obviously serial number is never going to contribute to the chance of admission of a student, right? So definitely, what we are going to do is we are actually going to remove this particular part. See, I am not going to discuss linear regression here actually, as there is a topic which is case study in the first unit itself. That's why I'm trying to show you a simple example. I will be directly showing you a final output, final product I will be showing you, because if I want to discuss linear regression, I will have to discuss the theory first, and then I will have to show you the implementation of the linear regression, and then I will have to come up with this particular thing, right? But that is there in your third unit, right? So maybe in third unit you will see that in detail. But as there's a topic called as case study in the first unit, that's why I'm trying to touch this particular example. Okay. So I hope all of you are able to understand what is going on here. So we have all these input features, and this is our output. Now, how many records we have, how many observations we have here, so you can check. If so, see in this case, as it's a very small file, definitely I can drag this particular file and I can manually check how many number of observations are there. Observations, I mean to say how many number of records are there, how many number of rows are there. Okay, so you can check it here. There are 500 number of rows. That means we have 500 records. So in our data, total records, how many total records are there? So total are 500 records, right? And 10 columns are there. And obviously, out of those 10 columns, one column is going to be the output column. Now, this is our complete data. Now, what are we going to do? We are going to divide this data into input and output, right? So, there will be input data and there will be output data here. So, what will be the input data? So, two input, X is going to be input. Suppose Y is going to be the output. So, input means what? Input means all those features except chance of admission, because chance of admission is output. So, this is how we are going to divide that one. Now, once that is divided, now this is what we are going to, this input and output or our data, we are going to divide it into training and testing. So this I am going to divide into training and this I am going to divide into testing. This I am going to divide into training and this one I am going to divide into testing. So I told you, for example, if we want to divide our data set as 70-30 training and testing. So how many number of records we have total? So we have 500 number of records. Just now we have I have shown, right? Out of 500, how many how many records I want as training data? So I want 70% of the data as training data. So what is the 70% of this? So you can check it. So it is 350. That means 350 number of records are going to be there in training data. So this will be what? X train. This will be what? X test. So how many number of records are going to be there here? 350. X test, so out of 500, 350 are training, so remaining are 150. So in X test, there will be 150 number of records. Similarly, same is the thing for output also. So corresponding to this training, input training, there will be output training. But as it's output, how many number of records are there? Obviously, as it's output, but as it's training data, there will be 350 number of records. And as this is testing data, so there will be 150 number of records, right? So what is this one? This is y train and this is y test. Okay, I hope you people are able to understand. This is how we do training and testing. Now Manas is asking, sir, should training data be always more than testing data? Yes, it should be, right? Because it's simple thing, right? See, uh, testing data, why are we choosing the testing data from this particular data set only? Because the pattern is same. See, what's going to happen is once your model is created, client should send us the data in the same format. Format should not change. There should be the same number of columns. Are you getting my point? That's why. And see, it's not like that I should select training data as 70 and testing data as 30%. I could have selected training data as 100% data also. Try to understand. But if I would have done that, then for testing, there will be nothing, right? Nothing which is there from training data itself. So whatever the data which client has sent us, from that data only, usually what we do is we try to select the testing data. Because what is the assumption between the parties? What is the agreement between the two parties in advance? The agreement is that whatever client has sent us, same data is going to be there in real time also. So I am talking about the format. Obviously, numbers are going to change, but the format is going to remain same. So are you getting, Manas? Yes, obviously that's why training data should be more as compared to testing. Even I could have taken only 2 records for testing. That's also possible. But just testing your model only with 2 records is not going to give a good idea about whether your model is going to perform properly in unseen data or not. See, whenever I say training data, it means that data will be seen by your machine. Whenever I say testing data, that means that data is not yet seen by your machine. So we want to check what our model is going to do in case of unseen data. And that's why we take some part of the data as a testing data, which can be as 20%, 10%, 25%, whatever. So that's why I will say that training data should be more as compared to testing data. Usually that's what happens. Is it clear, Manas? Are you getting my point? Or do you still have question? Okay. So see, whatever the training data we have in input, corresponding training data in output is this. So the input features and the output feature. This is input but testing data. This is output but again testing data. Okay. So what's going to happen now? Now, based on this training data, we are going to apply some machine learning algorithm. Obviously, we are going to do data pre-processing, data cleaning, exploratory data analysis, everything, visualization, everything. We will see whether our data is in numeric format or not. We will see whether our data is in normalized format or not, and so on. Once everything is done, then we will apply some machine learning algorithm. And obviously, we are not going to apply only one machine learning algorithm. Generally, in real time, we apply 6 to 7 algorithms at single time. And whatever the algorithm which gives you the best accuracy, that algorithm we select or that model we select as a parameter. And that's why it's really important to know about multiple algorithms. So if you remember, I told you even when I also when I conduct training, I generally talk about 16 to 7 machine learning, 17 machine learning algorithms, right? Because every algorithm has every technique has its own feature. So that is the reason, because we never rely only on one algorithm or one technique to create the model. Now what's going to happen is, once we apply machine learning technique, then we get a model. Okay, then we get a model, and now the model is ready. Now there is a time to test the model. How are we going to test the model? Now for that we need testing data. And why it is called as testing data? Because it's unseen data. That data is never seen by your model, and that's what we want to test, right? So what we will do is just to test. So obviously, see, if you go and if you try to check the accuracy of your model for training data, obviously it will give very high accuracy in case of training data, because it's already seen by your model. But this is the data which is not yet seen by your model. So that's why what we do is, this particular data we are going to pass as a input, as a test input to this model, and whatever the output you are going to get, that output is going to be our predicted output. That's why I will write it down as y prediction. Now the correct input, the correct output for this input is what? Is this y underscore test. So see, for x underscore test, this is the correct output, y underscore test. But for x underscore test input, what output our model has given? Our model has given this output. Now this is the y underscore test is the correct output, minus y underscore prediction is the output given by our model for the same data. So whatever is the difference between the two, obviously that is going to be error, right? So suppose for the for first record in the testing data, if the original output of the chance of admission is 92%, and your model is saying that the chance of that student is 88%, so what is the value of the error? Right? So our target will be what? Our target will be to minimize this error. That means what we will be doing is, we will be making use of something called as gradient descent method to minimize the error. That's where actually all these things come into picture, right? Gradient descent and PCA, or whatever we have seen yesterday, TSNA and all those things. Okay, so see, what are we going to do now? Yes, definitely we are going to develop the model, and I will be showing you the final output directly. So I will be showing you the output, how it is going to look like, how actually the model looks like, and what type of output you are going to see. So our model is going to give some output. Okay, and obviously there are different ways to see the output. Either you can make use of some front end, or you can make use of JSON file. You can pass the input in the form of JSON. You might be knowing that JSON actually stands for JavaScript Object Notation. So it's actually also one type of a document, uh, which is like a dictionary which stores data in key and value pairs. That's also one way. If you do not want to develop any front end or a graphical user interface, yes, definitely you can make use of uh, this JSON format also. Okay, maybe here also, if we get time, definitely we will try to talk about that way also. But what I want to show you here is, I want to show you a final product. So, and what you will see is, this is the overview. Whatever I have told you, this is the whole. So if I am talking about machine learning algorithm, so the module which I am going to show you, in that module actually I have made use of linear regression, a very basic algorithm which is used for prediction. So I make use of I have made use of linear regression in that. Okay, so this is the overview. This is what we are going to do actually in that particular module. So I hope everyone is able to understand this particular data set. You can see that in this particular data set there are 500 number of rows, and all these are the features. So obviously we need to import this particular file, everything. And see, in my case the model is already created, but to go and to discuss each and every step of the model, definitely for that first of all we need to discuss about the theory of linear regression, which I haven't discussed yet, right? So try to understand. Those who join late, I will be showing you the final output directly. Okay, so there should not be any confusion in your mind. But just try to look at this particular data. If you can see in this data, everything is in numbers. There is no text in this. So that is one good thing. That means we don't have to convert anything into numbers. It's already there. But one more problem with this data is that there are some missing values. Now, for example, in GRE score, say this is a missing value. Maybe there might be some missing values in some other column also. See, there also a missing value. This is also a missing value. So the columns like GRE score, university rating, they are having some missing values. And you might be knowing that count function actually by default ignores missing values. So that also we are going to check, or we already checked actually when we have created the model. But all those things are taken care in pre-processing. Okay, before implementing linear regression. Okay, so I hope what I'm expecting here is at least you should understand what is the problem statement and what is the expected answer. So the expected answer is our model should be able to give the chance of admission of students. Okay, now what I will do, I will close, I will minimize this file, and I will try to show you the final model itself. Okay, so see, actually these are all the files, or you can see these are all the nodes for linear regression. But generally, whenever we want to develop a model, whenever we want to develop final product, as I'm trying to talk about a case study, that's why I'm trying to show you a final model here. So whenever we try to talk about a final model, what we do is we actually try to make use of some IDEs, right? I think I talked about some of the IDEs initially. So if you remember, there are different IDEs I might have told you about. There is an IDE called as PyCharm. So PyCharm, whatever you can do in Jupyter Notebook, same code you can run it in PyCharm. But PyCharm is the IDE. IDE stands for Integrated Development Environment. Now see, this is how the file, this is .py file actually, this is a Python file, app.py. Whatever you are able to see in this folder, all these things, these are some of the files which we require in real time. Because see, what I will be showing you later on is when when I will be starting with third unit, in that case I will be showing you how to deploy your models onto cloud. A very simple example I will show you on a simple cloud, so that you people will also be able to make use of my model. So these are some of the files which we require in that case actually, proc file and all these things. See, once you apply any algorithm, any machine learning algorithm on the data set, and once we see that your model is ready, so this is your model. See, this is what your model is. Pickle is actually a file, like an executable file in case of Windows. So this is what my model is. So what I have done is I actually combined all the files, and I am trying to come up with a final product. So for that, what we need to do is we need to have all these files inside one folder. Don't worry about the meaning of all these files right now. Maybe later on I will try to explain you all these things, right? So everything should be in a one folder. Now what I will do is I am going to make use of one IDE here. As I told you, IDE stands for Integrated Development Environment. So there are different IDEs which are available for Python. Like PyCharm is there. There is something called as VS Code, which is also present in Anaconda. Then there is, you might have heard about IDEs like Eclipse. Eclipse is there. Those people who are using Java, they might have heard about something called as NetBeans. But generally for Python or for machine learning, these two IDEs are preferred instead of these. Okay, so these are the two IDEs. If whatever you want to make use of, you can. So as I said, there are notebooks. Notebook is a different thing. Whatever you are going to make use of, we are till now we are used what? Till now we are used Jupyter. So Jupyter is a notebook. There is one online platform that is called as Google Colab. It's a notebook, right? Then there is something called as Spider. Yes, Spider also you can make use of. And yes, there are different options. Jupyter Lab is also. But what is this? These are called as IDEs, Integrated Development Environment. So what we generally do in real time is All the cleaning part we do with the help of Jupyter kind of a thing or notebook kind of a thing. And then when we want to develop a model, we try to make use of IDEs like this. Okay, so that's what I am trying to show you now. So in my case, PyCharm IDE is already installed. What I will do is I will just right click here and open folder as a PyCharm community edition. I will just click on this. Now whatever you will be able to see, it will be a PyCharm IDE, and in that case you will be able to see code, and that code is a Python code with the help of basic Python. Okay, so let it open. Again, don't worry about how to install PyCharm IDE. Again, it's a simple thing actually. You just need to go and Google install PyCharm. You will be able to see a exe file and you can actually run it. So my purpose is just to show you how the product is going to look like. So Manas is asking, sir, we can develop model in Jupyter also, right? So we have actually developed the model in Jupyter only. Are you getting, Manas? The model is actually developed in Jupyter only. What am I trying to show you now? If there is a non-technical person, see, at the end of the day, the customer is going to be a technical or maybe non-technical. It is not expected that the customer should also know about Python language or R language or Java language or C language or C++ language, right? What he will expect, he only needs GUI buttons. So how to do that? That's what I am trying to show. That's, see, even though we use notebooks, but this is what we do in real time. We use IDE, integrated development environment. Whenever you want to develop a final product, you need to make use of IDE. So Manas, this particular thing, this is a model. And this model is actually developed in Jupyter only. Is it clear, Manas? Does it answer your question? So there we created this file. How to create this file? Don't worry about that right now, because that will be in the third unit. Maybe I will try to show it to you. Right. So as I want to show you a final product, that's why I am directly moving. I am directly jumping to the product itself. Okay. So it's like application. This is application which we have created. Now I'll be showing you how to run that particular application, and so that you will at least get an overview how the simple application or simple model looks like. So see here, this is whatever you are able to see actually, this is a Python code. So here what I have done is, here I have used something called as framework. Whenever you want to develop some web applications kind of a thing, we make use of frameworks. So here I have used a framework called as Flask framework. Those people who read about Python, those people who have done some courses, or those people who have read somewhere, maybe on the internet, they might be knowing. There are different frameworks which are available in the market. Okay. Again, Flask is a very basic framework. Many of you might have heard about this framework, Django framework. Similarly, there is something called as Flask framework. Similarly, there is something called as Falcon. Right now, there is a framework called as Fast API. Right. So Falcon is the fastest framework. Okay, generally, what we people do is, whenever some projects are there for development, some machine learning projects or some Python projects are there. So generally what we do is, depending on the budget of the client, you suggest them whether to make use of this or this or this or this, or depending on the requirement. So fastest framework out of all these is the Falcon. So again, there are different frameworks which can be used. So see, now what we do is, whatever you are able to see, it's a Python code. Now what I will do is, whenever we want to run any project, whenever we want to run any application, first of all, we need to make sure that there is an environment which is created in that ID. So to check whether the environment is created or not, you need to check it in terminal. So what I will do is, I will just go here and try to click on terminal. Once I click on terminal, I will be able to see the name of the environment here. See, this is called as environment. Now if you want to see from where actually I got it, so I am actually using Anaconda's Python in my case. If I want to show it to you, see, I will go to Anaconda, and there is an option called as environments. So many people are not aware about this. See, it's called as environment. So I am talking about environment. Now what is the environment? Always remember, for a separate project, there is always a separate environment. Because what happens is, if a project is related to healthcare domain, there should be separate environment for that. If a project is related to security environment, there is a separate environment for that. If a project is related to some some domain, maybe sports, for example. So obviously there should be a separate. So I mean to say, for a separate project, there is a separate environment. Right now I am using which environment by default? So by default, the environment name always is base environment or the root environment. See, right? Now, if you want to see this particular environment, see this one. This environment is created by user. That means I have created that environment. So ML for cloud deployment Heroku LRYPF. This is the name I have given. So if I go and if I click on these are all the environments. See, and this is the environment I am using. ML for cloud deployment Heroku LRYPF. I hope everyone is able to see. Right? This is the environment I am trying to make it. In your case, if you go to Anaconda Navigator, you will not be able to see all these environments in your case. Because I have worked on so many number of projects, that's why I have created number of environments in my case. Maybe if you people continue with this data science or machine learning or artificial intelligence or deep learning, definitely you will come across this one and many times you need to create environments. But many, if you are just a beginner, definitely everything will be done with base environment only. And that's what I have been doing in your case. Okay, so this is the environment name. This is the first step whenever you want to run any project. So in my case, environment is created. Now just go to run and run the project, and you will be able to see a link. Right, let me click on this, and it should show me a link with the help of which I can access the front end of that particular application. I can pass the values. Now see, this is the link which it has given me. See, now see, till now I haven't actually deployed this particular application on the cloud. Right, see, this is what I have. Now I will copy this particular link. I hope you people are knowing about what is the meaning of this particular thing. Right, so HTTP colon, what is this 127.0.0.1? This is called as what? This is called as localhost. Localhost means your machine, your laptop, your local machine. So this is the IP address, which is a reserved IP address for localhost. Okay, and after that there is a colon, and then there is 5000. So see, what I have done is I have created a web application, and by default web application always run on this port number. This is called as port number. Even if you think about www.google.com, so you might be knowing how actually internet works. So it also works with this link. This is just a URL, right? Uniform resource locator. But internally, actually, Google also has one IP address. I don't know whether you people are aware about it or not, how Google actually works, right? So whenever you click on this link, actually, you try to access some IP address. Okay, so the same thing is going to happen here. So 127.0.0.1 is actually a local. It's a link. It's a IP address for my local machine. As now currently the application is running on my local machine. Okay. So and there also you are going to require port numbers for different services. So by default the port number for your application is 5000. That's why it has shown is 5000. So what I will do is, let me clear this. I already copied this. Copy it. I will copy this particular link. I will go to browser and let me open a new tab, and here I will paste it. And now I will be able to access that particular application. Let me just press enter here. Now see, this is the final application which I am able to see. Now I already introduced you about the problem statement, right? See, GRE score. GRE score is out of 340 marks. TOEFL score is out of 120 marks. University rating is out of 5. Statement of purpose is out of 5. Letter of recommendation is out of 5. CGPA is out of 10. And this research done or not, either yes or no. And once I go and once I click on this predict button, it should show me the result of the chance of admission of that person. Right? So I will enter the value. Suppose out of 340, someone has got 299 marks. Out of 120 marks, suppose someone has got 110 marks. University rating out of 5 is suppose 4. Statement of purpose, suppose 3. Letter of recommendation, suppose 4 out of 5. CGPA out of 10, suppose someone has got 8. And whether the research done or not. So yes or no, right? So yes, suppose. And now if I go and if I try to click on predict, it should show me the chance of the admission of that person to get admission in foreign university for masters. Okay, let's see. And obviously, this particular module should be running in the backend. See, your chance for admission is 6%. Actually, it's 60%. I just need to go to my code and multiply the answer with 10. So, your chance for admission is 60%, right? If those are the marks the particular person has got. So, see, this is a final product. So, in this case, what I have done, I have created a web application, a simple web application. Now, if you also want to access my application, actually, I haven't shown you how to deploy the application onto cloud, but some of the applications I have already deployed onto the cloud. See, there is a cloud called as Heroku. Even you people will also be able to create these kind of applications. Maybe better than this actually. So you created an environment using Jupyter and used Heroku to put on a cloud and use the local host IP to access it. Right? No. Whatever the application which you are able to see, Manas, whatever the application which you are able to see right now, that application is not on cloud. Okay, this is not on cloud. This is just running on my local machine. That is one thing. How I created the environment? I created the environment using PyCharm. But what happens is it is making use of Anaconda's Python. That's why that environment name I am able to see. Try to understand. Okay, I haven't created the environment from here, but I created the environment from Jupyter. I could have created the environment from Jupyter also. That's possible. But how am I able to see that environment name here? Because I am using Anaconda's Python. See, if you want to make use of Python, you can directly install Python. That's also possible. And go and use terminal. That is one. But I use Anaconda's Python. And same thing I am using here. See how to create the environment. Let me show you. Go to file, go to settings. Once I am in setting, go to project interpreter. Once I am here in project interpreter, click on this gearbox, this setting option here. Then click on this add. Once I click on this add, here it is going to ask me whether you want to create a Conda environment or a virtual environment. So in that case, I selected Conda environment, and that is the reason why I am able to see the same environment which I created with the help of Anaconda's Jupyter. If I would have selected virtual environment, then the name of the environment which I have given here, I would not have been able to see the same name in Jupyter notebook. Right? I hope it answers your question. Obviously, for all these things, okay, Muhammad Wasif Raza. Even if I am telling you that do not write down your numbers and names right now, but still you people are writing, right? See, if you do not want to understand all these things, I will stop. No problem. I also do not have that much of time. Right? I'm just trying to tell you all these things for your information. So, Wasif Raza, just wait for some time. I will give you 10 minutes. If you have any question, then you ask. Okay? I hope it answers your question, Manas. Okay. Okay, let me finish it fast because people are in hurry. So yeah, no problem. So yes, this is what you people are able to see, and this is what your final product is. This is what your final answer, right? Okay, guys, this is what I wanted to show you. Maybe okay, I will give you 10 minutes because people are they are really in very much hurry. I hope you people have got a basic idea here. What is that problem statement was? What was the problem statement? So that was a case study actually, a simple case study I tried to talk about in which we are using linear regression. But yeah, don't worry, I haven't talked about linear regression yet. Whenever I will talk about it, definitely this thing is going to be more clear. Okay. Okay, guys. I hope everyone has got a basic idea about all this thing. So I will just